stimulus. Okay? They're already going, now? Just wait, okay? So, they're already receiving some stimulus because information that's here has traveled the spinal cord and it has to exit the spinal cord. When you look at, well, that's a little hard right here, okay? You know, when you're looking at this model, you see these yellow plastic thingies that are exiting from the vertebra? Those are my spinal nerves. Okay? So the information that's going to travel down that would be needed to make sure I stand up, have my correct posture, move one foot in front of the other, the information is traveling by way of this spinal nerve to those muscles, okay? And because it's going to make those muscles act, it is a motor neuron. Think of a motor. A motor makes something move. Does that make sense? So it's these big spinal nerves that are coming around, going down, going down, going down, going down. It's those big nerves that are meeting the big muscles. And when a big nerve meets one of the big muscles and penetrates through the epimysium, it begins to branch. And it will continue to branch and branch and branch till it meets every fiber. So the stimulus that the muscle receives from this higher order thinking that we're doing, okay, is going to cause, it's going to lead to the ability of that skeletal muscle to respond. That is the stimulus. Alright? Now, a lot of things have to happen for that to occur. I know when I showed the little video, and it's like, oh, you know, the myosin head will do this onto the actin, and it's a relatively simple, how do they word it? That the muscle contraction was something relatively simple. I want to just be like, oh, dude, I need to have a conversation with you. All right, it is not simple. It is complicated. It is extremely clinically significant. Okay? I can't stress how clinically significant the muscular system is. Okay? Now, I need to understand some of this structure that I have in the muscle. Okay? So, you'll notice, and I've only got right, I'm trying to figure out the best way to distribute. Okay, I'll work with them. Carolyn, can you work with them? Maybe move over there with them. Maybe can you guys kind of share right here? Okay, Gordon, can you kind of maybe share with her? Okay, and we'll work with this one right here. Okay? Now, at first glance, this looks kind of weird. Okay? So, actually, Karen, do you want to come up here with Greg? No, do 2, 2, 2. We're good. Okay, good. 2, 2, 2. All right, good. Now, what this is trying to show you, okay, it's trying to give us an idea of the muscle all right? And so when I look at it this way, and I look at it this way, it's kind of like confusing when you first look at it. But let me explain what they're trying to show, okay? They're trying to show some of the connective tissue wrapping with this right here. Because one of the things about connective tissue wrapping, it's got a lot of fibers in it, okay? So it's trying to show me some connective tissue wrapping. Now, for this portion right here, they're trying to show me the nerve. See how they kind of got like what looks like the nerve coming in? Okay? So they're trying to show me that nerve entering into the structure of my muscle. What they're showing us is it entering at the level of the muscle cell, the muscle fiber. Okay? So, if I were to have a muscle fiber this long, that nerve only enters at one point. So if it only enters at one point, how does it stimulate the rest of this fiber that might be this long? Any idea? How is it, if it only touches the one part? Do you know why it does that? How it does that? We gotta look at some of these components to it. Because the muscle cell, aka fiber, okay, doesn't follow our thinking about a cell, okay, where we would think of something being just kind of round and that's it, okay, we're now looking at something that's elongated, tubular, got multiple nuclei, but because it's a cell, it will still have parts of a cell. I mean, if we got nuclei, okay, just more than one, I'm still going to have a cell membrane. I'm still going to have endoplasmic reticulum. It's just different because this is a cell that now does this. Okay? So, if I look at my cross section, all right, all of this little wiggly lines looking stuff, okay, this is representing my plasma membrane, okay, sarcolemma. Sarco for muscle, lemma for the membrane, okay. Each one of these, okay, each one of these is letting me know it's my myofibril made up of my protein filament. All right, can everybody see the different colors of the banding here? All right, I am now down at those protein filaments of my actin and my myosin. Now, this part that looks like a web, okay, this is my endoplasmic reticulum. You guys remember that from just a regular cell? Mm-hmm. Okay, so that's my endoplasmic reticulum. Note how it goes around a group of my protein filaments. And then it looks like it's so many distances, all right, I've got these tubes, all right, these are my key tubules. Here's what can happen. Now, how many of y'all have ever heard of a neurotransmitter? Like what? Or what does it do? Endocrine system. All right. So something like a message. Something like a message. So we're all in agreement that it's a message. Okay? Yes. All right. Now, neurotransmitter. That is telling me it's from the nerve. Look at how they're representing my connection. I've got a nerve coming right there into a point on this fiber, on this cell, and it's meeting a lot of that squiggly stuff. Everybody see that? And then that squiggly stuff kind of gets nice and smooth after a point. If it is a message, there is some communication between my nerve and the cell. And because it's only at that one point, all right, I've got to make sure the message goes all the way down that cell. My T-tubules are going to help to do that. All right, so is everybody with me right now on the anatomy of this? I'm looking right now at one cell, one fiber, made up of all of these little actin and myosin, actin, myosin, actin, myosin, actin, myosin, actin, myosin. Is everybody kind of with me? Okay, so looking at that structure where the nerve is going to come in, we're going to have the release of a neurotransmitter. There's going to be some stuff that has to take place between the nerve and the muscle cell, and then I've got to worry about passing that information along the entire fiber. So, if I think about this whole series of events that's going to take place, okay, this means that as we sit here right now, and if we think about moving anything, okay, that is coming from a higher order thinking. So the stimulus and a couple of difficult pathways is going to travel down the spinal cord to that spinal nerve, to the muscle as a whole, and because the nerve enters the muscle and begins to branch, the release of the neurotransmitter does not take place until you get to every single cell, every single fiber. So, once it gets to that fiber and that neurotransmitter gets released, it's going to set off a series of reactions in that cell. All right? That cell is made up of my protein filaments. Now, actin, myosin, actin, myosin, actin, myosin, actin, myosin, it goes around in the circle. This circle right here, with all of this different banding, is showing me the connection between actin, myosin, actin, myosin, actin, myosin, actin, myosin, all the way down. Do you see how it looks like it's separated by every single one of the T-tubules? Now, the structure of this actin and the myosin and the events that have to occur are going to be what makes the muscle contract. Because, in the famous words of my granddaughter, guess what?